Hello, and welcome to a Tech TouchDesigner tutorial. Today, we're going to be making this network, which outputs this really fun AR scene. We've got two green balls here that are controlled by a leap motion sensor. I'm wearing an Oculus CV1 right now, as well as a ZM camera attached to it. And combining these three devices with TouchDesigner, we can play this fun interactive game where you make sure these spheres don't collide with each other. So to start, we're going to go ahead and delete this scene, start from scratch. Now the first thing you're going to want to do is set your FPS to 90. By default, it's 60 in TouchDesigner because that's what all of our regular monitor devices use. But in the case of Oculus, the Rift top, this requires 90 FPS, as well as two sources. And we're going to dig into that in a bit here. But for starters, let's start with all of our device setups. So first, we're going to need this Oculus Rift top. We're going to want to get an Oculus Chop, and not just one, but actually three. So this first one, we're going to be using the HMD output, which gives us all this really, really useful positional information about the head-mounted display, HMD. If we duplicate this, we're going to do the left projection matrix as well as the right projection matrix. These are both very important pieces of information for the Oculus. And finally, if you're just setting your Oculus up for the first time, you're going to want to make sure that it's running and working. So make sure to download, download the Oculus app from oculus.com/setup, and make sure that your device is connected and plugged into USB 3. I'm plugged into USB 2 here, but it's still working, but USB 3 is recommended. By the way, it is a USB 3 port, but I'll tell you, Oculus is really fun to set up on a wide variety of motherboards. Have fun with that. Okay, so anyway, we've got these three set up now. So those are going to be our inputs for that. And then we're also going to want a leap motion chop. And if you're using version 4, that's awesome. I'm on a version 2. And so now you can see that that positional data is working. And make sure, of course, to download and install the Leap Motion drivers if you haven't from leapmotion.com. But they're pretty plug and play. That's the beauty of TouchDesigner. You pretty much plug it in, and it just works. Lastly, we're going to want to get the Z tops up and running here. Z's wonderful, wonderful little device. I've got the Z Mini here. And so now you can see I'm wearing the Oculus on my head right now, so you can see where I am and that this is in fact working, and all that positional data is going through from the headset because it's head mounted here. We're going to need one for the left perspective as well as one for the right perspective to get that true 3D render going. Okay, so now we've got all of our devices inputs as well as outputs mapped here, and starting to get things structured. So let's start off with this leap motion down here. Now, obviously, we've got two hands, 1 and 2. So we're going to want to put down two select chops, 1 and 2. And from this data, we're going to want to extract the hand 0 and hand 1. So one for each. So this is going to be hand 0. This is going to be hand 1. And what I want to get is the positional data of the hands. So the TX, the TY, and the TZ. So we'll start with hand 0, and we're going to find the palm here. And we're going to do palm TX, palm TY, palm TZ, or Z. So now we're going to do hand 1, same exact thing. Find the palm TX, palm TY, and palm TZ. So basically now you can see I've got the position of my hands. So right now, if I go ahead and throw this up full screen, you can see I'm moving my hand here, and you can see that there's the X, there's the X, there's the Y, and there's the Z. So we got that information moving here correctly for that hand. And if we try the second hand, it does seem to be working as well. So as you work, it's always good to check, make sure things are behaving the way you expect. Of course, we want to throw down a couple nulls here. A really useful keyboard shortcut, Alt-N, creates a new null and plays the nice, lovely Windows chime. If anyone figures out how to disable that, let me know. And now that we've got these nulls, we're probably going to want to label them because this is important to not get confused. So we'll call that hand left, and we'll call this hand right. That way we know which is which. And next, we're going to want to put these on some geometry. Make sure that the leap motion data is controlling the geometry. So I'm going to throw down a sphere right here. And what I like to do, just to keep things simple, is get my radius that I'm going for, which is usually very small for geometry, and then copy and paste that there. And we'll leave it as a mesh. That's fine. And I just like to zoom in on that. If you don't know how to do that, hit the A key on your keyboard, and then adaptive homing is the Q shortcut on your keyboard. So if it's all the way out here, you want to disable adaptive homing is usually what I do, and then hit H to home in on it and select it, just to keep things nice and consistent here. So now right click on the geometry and we throw down a geometry comp. This will automatically toss the sphere into the geometry comp, which I find is really useful, because if you just lay down a normal geometry comp, it automatically populates it with a torus inside, which that's fine if that's what you want. But in my case, I want spheres. So rather than creating the geometry comp and going in here and then deleting it and then making a sphere and taking all this time, that takes forever. And then, well, what if I just wanted to adjust the size of the sphere? What if I wanted to adjust any of its properties? I have to go into the geometry comp each time. So really nice shortcut here. So just right click on the geometry and throw in a geometry comp, just like that. Beautiful. Now we're going to want to add a little more space between these, I think. Keep it even. Keep it symmetrical, somewhat. And now we've basically got our spheres added here for the geometry. But of course, we're going to want to control these. Now, the best way to control these really quickly is to select these, hit A on your keyboard to make them active, and select your destination. So in this case, we're going to call this geo underscore left hand and geo underscore right hand. Or you know what, maybe we'll say geo hand right and geo hand left. So that way things are consistent here. We got hand left, same nomenclature, nice and straightforward. Finally, we'll drag this up here to the translate X. So now we see that that's feeding in, and indeed, if you look at the 3D axis there, we can see it's actually moving on the x-axis. Do the same thing for, I'll try and do the same thing here for y, and same thing for z. And bada bing, bada boom, we've got a moving sphere controlled by the leap motion for the left hand. And let's do the same thing for the right hand. So drag and drop that up. X, Y, and Z. Did I get Z there? Yes, I did. Great. And always save every chance you can think of, because they're small files, folks, and you don't want to lose work. Things do crash from time to time. So we'll make those unactive again, shortcut A on your keyboard. All right, so now that we've made that first section here of two moving spheres controlled by the leap motion, we're going to move on to the next section, move this over a bit, and start another sphere. So actually, let's just copy and paste one of these spheres, keep things simple. But instead of a radius of 0.01, I'm going to do a radius of 0.05 because I want these spheres to be a little smaller than these ones. Then these, pardon my English, these ones is incorrect. Now, I'm going to add this to a geometry comp, just like that. And we're going to set up instancing for this. So we're going to get a bunch of GPU instances, which is really fun. And for starters, we're going to want to set up a constant chop. Now, these are really useful, these constant chops, because we can set up parameters. So I'm actually going to call this one pars for parameters. Maybe I can go params. That's a little more succinct. And for these params, let's start with the num particles. So this is the number of total particles we want. Now, these particles, they're going to be based off of noise. Let's add a noise top. And, you know, the number of particles is basically the resolution, the width times the height. So you can see here pixels. This would be 65,536 instances by default. Well, we don't want that many instances. I'm happy with something like 10 by 10. So, but if I put 10 in here, see, then that's not really going to work because the resolution needs two variables. It's a vec2. So instead of 10, let's put in the total number of particles we want, 100. And let's do a little math in this, which is really fun. So the beauty of TouchDesigner is adding Python, making this really smart. And so when you think about it, what we're referencing is this parameter, right? We want this to control the number of particles. So let's go ahead and throw it in here as a chop reference, as well as here. All right, so far so good, but we're still not at 100 particles total. We're 100 times 100 instead of 10 times 10. But I wouldn't want to really do division by 10 because that's not going to work if we change the particle numbers again. So to make this a little more intelligent, let's use a little bit of math here. So we'll call the math and square root out of the math. And we're going to wrap this. And let's see here. I think that should work, right? Because what we're doing is taking the square root, using the math, calling the math function, the square root, and applying that to this, basically square root. So copy, paste, and don't forget the last parentheses, just like that. And boom, we've got our 10 by 10 from 100 particles. So if we change this to 200 particles, it is going to do 14 times 14, 196. So not 100% accurate, but pretty close. And as long as the number can be, you can get the square root of it, you will get an exact number. You know, this kind of looks a little ugly. It's interpolating the pixels. Let's do nearest for this. This looks really sharp and really nice. And for these sort of textures, nearest is ideal. So now that we've got our main noise top here for our particles, let's go ahead and toss that in a null. Always good to have these. And we're going to use this as the particles pause for the particles position. Let's go ahead and name this geo. Call it particles. That way we know what this is going to be. And if we go ahead and copy and paste these, that's really slick. It takes that and applies it to both really fast. And this is going to be our particles scale, because we want to add a little bit of scale to this just to make them a little more dynamic. So if we go over to the noise tab again, let's turn off monochrome. So now we've got RGB channels. And the beauty of RGB is that that is exactly like XYZ. So particles pause. Let's go over to translate. And let's choose R, G, and B. And just like that, we've got our particle positions. Now, of course, as you can tell, this is normalized. We're going from 0 to 1 here. So let's go ahead and take that back to a 0 offset. So actually, everything's beginning from the center here. But of course, you can still tell that we're in 8-bit world, and we don't want 8-bit pixel values. We want things to be a little more accurate. Now, a lot of folks will go over to 32-bit, and I respect that. You know, 32-bit, it is more accurate for sure. But when you're comparing from a visual aesthetic, 16 and 32, very, very close. So more often than not, I go with 16 and just see how far that gets me. And if it's still a little choppy and things aren't moving as accurately as I want them to, then I'll go over to 32. But remember, the higher the bit depth, the more processing power is required, the more memory is required. 16 keeps things just a little more, utilization is less. Now, that being said, what are we talking about here, Dylan? This is 10 by 10. This is nothing. So crank it up to 32-bit if you're working with really, really small textures, because it's using almost no memory. This scale amplitude, I think I want to take it down a bit. So I don't want it to be quite 0.5. I want it to be a little less. And the offset, same thing, maybe not 0.5, maybe a little less than that. Because if we're going, from 0 to 1, some particles are going to just disappear completely. And I don't want that. I want them to be a little more gray. That's nice. Now, for the exciting part, we want to see these particles actually move. And one quick way to do that is to do a transformation. Now we could do this transformation any number of ways, but really fast way is abs_time.seconds times 0.05. Gives a really nice smooth result. It's not moving too fast, maybe not too slow, but just right, kind of there in the middle. And same thing for scale. And rather than typing it all out again, I'm just going to copy that and paste it. Yeah, great. So we've got some nice movement going on here. And but we haven't applied the scale yet, so let's not forget to do that. We'll add scale to the instance scale op. And rather than clicking, I'm just going to type RGB a little faster. And now you see that we've got scale applied. However, it has the same seed as the other one. So we're getting a very non-random scale effect going on because these noises are basically identical to each other. So one easy way to solve that really is just to adjust the seed. Boom. Now we're talking. That's a little more randomized, a little more natural. What I'd like to do is use this Z camera render as a bit of a texture itself. So we grab a select top and drag the Z onto it. Now we can move this elsewhere in the network without having to do a really long cable connection, because those get just disgusting. This is disgusting. So this select, I'm going to use this as an environment map. So that way the lighting of the spheres changes dynamically as I move the camera around. Now, the important thing to remember with this is that environment maps are very taxing on the GPU. And so I'm going to throw down a resolution top here, and I'm going to change this to be much, much smaller. So custom resolution, I'll do something like 120 by 80, just something much, much smaller, right? And as you can tell, it doesn't look very good, but this is an environmental. And since it's environmental, let's go ahead and blur it a bit. I think use a value something like 3 and 11. The more pre-shrink you use, the faster this is. The higher the filter size is, the slower it is. So definitely try and balance those out. But now we got a nice blurred image, good environment, nothing too obvious. And finally, we'll add a level top here, and go ahead and take the brightness down just a tad for compositing's sake. We don't want this to be too intense, especially given the fact that we're going to be making colored textures here. So I think that's good to go. Alt-N, keyboard shortcut to add a null, and I'm going to call this enviro map. So that way we know that's what that is. Save the file, Control S, always, always, always. And now let's go ahead and make a null comp. What's great about null comps is that you can combine different 3D assets, such as this hand left, hand right, and particles, from the top of each container into bottom of the null, and we'll call this master transform, or even master position, master pose, just to keep the naming scheme consistent here. And what's great about master pose is now we can move all these together in the same scene. We don't have to worry about moving one and the other. This is null objects are wonderful, and they're really cross application, very important to use. Now we've got this environment, but what are we really missing here? The materials, of course. So if we go over to the matte tab here, we're going to use, instead of PBR, actually just good old Phong, 2 of them actually. And what I love about Phong is that it has an environment map right there. So if we drag this environment map into it, you can see that now we're affecting this Phong material based on the camera input. And that's really, really fun. Now, as for these colors, let's go ahead and choose a light green, something like this, a limeish green. And we'll do the same thing for the emit as well. Just a nice little lime green there, maybe not quite as intense, just to give it a little bit of a glow. I think that's good for now. And you can see there that the texture is starting to take shape, but and this Fong, we're going to name it, of course, so that way we know what it is. It's for the player, because this is really all player stuff. And then go ahead and copy and paste that, move it over here, and we're going to call this Fong enemy, because this will be for the enemy section here. These are all enemy particles. And but enemy, of course, green means good. But enemy, you want a little more on the reddish orange side, so we'll make that reddish orange there, and probably the same thing for the emission. Maybe not as dramatic. So we'll go a little dark there and see how that ends up looking. All right, and finally, let's go ahead and get this added. A little easier just to drag it directly on the material and select the material. And sorry, drag it directly onto the comp and select it as a material. So great, now we've got our elements are lit and animating, and are using the materials here that we specified for these objects. And we've also parented them to the master pause null. And what's great about this is now we can move this all these elements around, and you're going to see how important this is in a few here once we start getting this hooked up into the AR scene. All right, so our scene's starting to come together, but of course we're missing one of the most important ingredients, and that is the actual 3D renders and camera setup for this geometry. So what I'd like to do now is start off with camera. And this is fun because then we can see our actual 3D scene and see things are starting to come together there. But we're going to need two cameras because we've got two eyes. So we're going to have a cam left and we're going to have a cam right. But to save myself some time, let's go ahead and just focus on cam left for now, because there's a little bit of stuff we've got to set up here. For one, inside of the pre-transform, we're going to want to apply a pre-transform on this, because you can see down here there's a transform matrix. And the transformation matrix is really a really amazing feature, especially in regards to the Oculus, because what we're going to want to do actually is get, again, using a select, not a serial, we're going to select the, you probably guessed it, IL. And this gives us all the left eye information, right? Really useful. And we can even call it select eye left. And we're going to do the same thing as you probably figured for the right eye. And instead of IL, it's IR. And so now we've got both the left eye information, positional information, as well as orientation. And we're going to apply the left eye to the transform matrix for cam left. And what we're also going to want to do to this camera is go to the view tab here, and you can see that there's a projection matrix chopped at here as well. But right now we're set to perspective because that's the default. But we're going to want to change this to a custom projection matrix. And now the projection matrix opens up. And what we can do here is take the Oculus Rift 3, but let's go ahead and rename this to left matrix, and for right matrix. Again, you can see here, I need to keep things consistent. This should be matrix left and matrix right. And you may be asking me, well, Dylan, why does that matter? Because again, if you're developing a TouchDesigner scene, the most important thing is consistency. Eye right, matrix left, matrix right. Keep things consistent. That way, when another developer is viewing it, they can find their way around. So let's go ahead and plug this into or drop it in to the projection matrix for this camera. And it looks like we're good to go there now. And we'll kind of keep these things a little tidy, a little tidying up here. And finally, we can copy cam left into cam right. But of course, we don't want to use cam left for that, we want to use cam right for the projection matrix for the view. And then for the transform matrix, we're going to want to use select eye, right. And there you have it. So now we've got the basic setup here for the cameras. And you can even tell a little bit when I'm moving my head around here that this is working and that these particles are actually rotating around. So now the next big step here is to add a render top. But remember, it's not just going to be one, it's actually going to be two, because we're going to have the render for the eye left and a render for the eye right. But before I get to the eye right, let's just get some stuff set up here. So first of all, Oculus, most VR devices are not using a resolution of 1280 by 720, but they actually do pass this information to us through the HMD, which we have up here, as a matter of fact. The resolution is passed through. We just have to know where to select it. And at first I got confused, but then I remembered, device information, here's where our render stuff is. So remember, acceleration, velocity, all this fun stuff. Ooh, velocity. Oh, that's really fun. And acceleration, that one's just crazy. But device info, this is really useful because we need to know our render outputs. And so same thing, to keep things easy and visually understandable, let's select res. And we're going to have some fun typing all these out. But essentially, it's render L width, render L height, and then render R width, and render R height. Beautiful. And now we can see we've got our renders. Now, I don't know why we would need to have these, because eye for an eye, they're the exact same dimensions, but who knows? Always best to play it safe, right? You could probably just use, left and be done with it. But again, nice thing to be specific. So now we can go ahead and drag the render width and render height, just like that, into the L for the left eye. We'll go ahead and save now, just before we forget. And so now we've got the correct resolution there. You can click the corner there and get it nice and tidied up. But you can see no camera comp is found. Rendering results may be crazy. Well, of course, we need to add the camera comp to it. So let's do that. Okay, and now you can see that we have an image, and then it's feeding through, and I'm moving my head now, and the image is moving as well. You can see here, move. Oh, wow, yay! So that's working. Fantastic. So we've got that set up here. And, we're going to do instead of copying and pasting this, actually, this is a render top. So specifically, we have this lovely thing called the render select top to increase our efficiency a little bit more. So render select is going to select this render. So it's going to reference that top. But before we get too far ahead, let's not forget that, well, if this is going to be the render select for the eye right, then we're going to need the eye right camera. So let's go ahead and add that up here, cam right. So now this has the information from both cameras. Very important to have that in there. Let's see here. First of all, our color buffer index needs to be 0, and our camera index needs to be 1. There it is, right. I was wondering, why are these grayed out? Oh, right, because it's a render select. So now that is selected, we're using the camera index 1, because you can imagine that this is 0, this is 1, so we're using the second camera information, really useful there. And the color buffer index is the same color buffer. It's not 1, it is 0. So now that we've got that, we've basically got both of our eyes rendering. Beautiful. At least, for that part of it. Now, Z is going to be used for these eyes. And so I'm going to call this Z left. Oops, yes to all, but before I get too camel casey there, I can't help myself. And that's great. That didn't unlink. We'll do the same thing down here. So Z underscore right. So we've got our left eye and our right eye. Beautiful. Those are set up, ready to go. We're getting there. We're getting closer and closer. All right. So our final step here is compositing both eyes together, and this is a crucial one. And may be very specific to your eyes and your vision. But for starters, what we're going to want to do basically is pipe these into the Oculus. But we're going to want to pipe them together because we want, for AR, we need the environment itself, right? Which is the Z feed, and the 3D render, our render out of touch. Now, as you can tell, they're two very different resolutions, and that is an important consideration for this. And we're going to conquer that with the over top because over top is really fast and really simple. Now, and so what we want to do is, instead of fill, we want to fit best. And we're going to use input 1 as the default. And so now you can see that the render is happening over, or rather it's inside of the Oculus. And this is what it will look like because the field of view of the camera is much smaller than the actual Oculus. The Oculus is very wide, whereas the Z is a little shallower. And so this way you see the entire Z render in it correctly, and it doesn't give you the problems. Same thing down here. But before that, I want to do something a little fancy here, and that is going to be through a really simple composite here. And the operation is going to be screen. I like to set my blend mode first. And let's middle click instead of right click. And that will basically pipe off another branch of cable. Instead of middle clicking, it'll add it to this cable. So sorry, right clicking will add it to the existing cable. Middle click branches off in a new one. And then we'll pipe that right back into the comp. And we're going to move it up one, keep this nice and organized. And for this blur, let's try out a little more of a pre-shrink, something like 4, and a filter size, something like 12, 14, 13. Great. And so basically this is adding a nice little post-glow effect. So these look like they're actually emissive, because if you can remember from the Thong, we added a little emit there. So we want these to appear, slightly emissive. That's really nice. And so now we've got our base composite going on there. Fantastic. And this seems to be set up the way we want. So now I can go ahead and copy paste down to here, and we'll just wire this in. So there, we'll go there into that blur, and this comp, what we're going to do is take this render instead and this blur instead, and we'll pipe it into the over right there, and the Z finally, just like that. Great. So now we've got both eyes comping. Fantastic. That's looking good there. And now, the moment we've all been waiting for, right? Will this actually work? So let's drag it up here. In case you're wondering, left eye, right eye. Just hover when in doubt. So pipe that in, and oh yes, looks like we've got something. And oh, I can see something. As you can see, I've got something to see. But the while the orientation is working correctly, it appears that the position data is not reading through. And you probably would have figured this out if you're at all familiar with VR and just rendering in general, because you'll see these particles are really, really tiny. And they are not where they're supposed to be. So what we've got to do now is get them into the position of where they're supposed to be. All right, so after a little digging around, I figured out what it was. And when in doubt, you got to go back through the network and see if you missed any steps, and I totally did. And in this one, it was the translation. See, this needs to be zeroed out, as well as this. And by default, TouchDesigner uses a position of -5Z, or rather positive 5Z, which makes sense. But given the fact that this is VR, we actually want to be zeroed out. So now you can tell that the particles are indeed very, very close to us. And if you wear it in your headset now, which let me go ahead and pipe this out into a null object here. And actually, before we do that, to make this really nice and viewable, especially if you're doing this for a client or something, add a crop. And what's great about a crop is now we can go ahead and take that off of there. And in fact, let's get a little more precise here, like that. And then same thing off the top, like that. Beautiful. And now we can go ahead and throw this onto out, let's say. And now finally, let's go ahead and view that. So now, as you can see through my headset, we've got all these beautiful looking spheres just orbiting around, and they're right next to us. Now, if you put your hands in front of you, you may get a little dizzy right now. And indeed, there is something very, very off on this scene. And you know what it is? It is the fact that both eyes are rendering from the exact same position. Because what we're doing is overlaying these renders of the Z on top of each other. So you see like the particles themselves, the spheres, these look fine. These look great. They're rendering in 3D because we've got two different cameras for those. But the Z itself is actually treating it as if the Z left and the Z right are right on top of each other. And we don't want that. What we want to do actually is simply shift these over ever so slightly using translate. And what works for me, and again, everyone's eye will be just slightly different, but what works for me is a translation. Actually, I'll go ahead and use the overwrite, but it doesn't matter. You can do one or the other. Translate this to -0.02. Now, the reason I'm using the right actually is because we're rendering from the left in other parts. This renders from the left image by default, this Oculus Rift. So, right, that's always how you can tell is well, we moved this one over, we didn't move this one over, it looks like this one, so therefore it's using the left eye. So that's why I did the over for the right eye instead of the left. So now if you go back in the headset, you'll see, oh my gosh, wow, it looks 3D. And it is quite a trip, I have to say. Just seeing everything in 3D space inside of these, really, really fun. So we got all these spheres moving around, and I'm going to try and see if I can actually use this through the headset, which I have to say, it is a little low resolution. But if we remember, we made this master null here, and the master null right now is set to a scale of 1. So if we take this scale down, you'll see that everything shrinks. These particles get smaller, everything shrinks. And then if we move these back, you can see, okay, wow, oh, and there's the green again, great. So it's all about adjusting the scale to the needs of your scene. Now, you may want really big particles, and that's fine. For me, I wanted, medium-sized particles, and probably bring them down just a little bit more like that. Great, and you can see they're tracking in the scene. And now finally, moment of truth. Move this hand, aha, they're moving. But as you can tell, they're a little bit to the right here. So easy to do that with the master null. Simply take the translation and move it a bit more to the left until you see it works. We're working here in desktop and VR at the same time. Pretty crazy. What a time to be alive. And let's move these down just a little bit more, maybe slightly smaller, slightly bigger. Find whatever you like. And now you can see we've got our hands moving, and the spheres are indeed moving, and we've got ourselves a fully interactive scene. We've got these spheres. We've got a beautiful, pseudo photoreal lighting. Now, like I said about the lighting, always come back to the levels, and start adjusting it here. And you can see, the difference it makes. So, maybe you want your particles darker, maybe you want them brighter, tune it to your environment. And, for my environment in particular here, you see there's 2 windows back there. And so what I like to do is grab a light comp, right, and move it back in the scene. So I think that's going to be -5. And, all right, let me check here. Let me break out of the VR for a moment because that's getting a little hard to see stuff. So I'll call this light and window 1. And then I'm going to just check my position here on it. And what's really fun to do actually is just move it around in the scene, because you can tell where my Oculus is. That's a big camera. So knowing this, then, that if I'm positioned here, then the window is actually like right here, approximately. And what's great about using active mode is you can get, a pretty accurate translation and orientation very, very quickly. It's perfect for prototyping. Really fun. And go ahead and make this dimmer a little brighter here, because those are somewhat bright windows right now. And same thing, I'll do window 2, and maybe I'll move it over just a little bit to the right here. And so same thing like we've been doing. This is left from my perspective, and then right from my perspective, so we know exactly which is which. And now if we take a look in the headset again, you'll see that we've got a really nice rim light going on. And this is the beauty of compositing, is understanding your environment and knowing that, okay, well, light's actually coming from back here. So it makes sense to make a 3D light that comes from the same source. And that way we know, or at least our minds are more at ease, that these graphics are actually in this environment. Now, it's a 3D scene and we're just getting started here, but the principles of lighting are the principles of lighting. So even if you're not going for photoreal, you're just going for something that's tasteful and makes sense in your environment, then this is the way to do it. Treat the physical world in the digital world. In AR applications, make sure that your lighting sources are at the very least consistent. And so how cool, how fun. Hope you enjoyed this tutorial. Enjoy, have fun, have a blast. That's what this is all about. Cheers.